We're going to work on an ALEKS problem that deals with predicting the type of solid formed by a compound. Now, ALEKS has listed three major types of crystalline solids, and the first type is called molecular solids, and these solids are made up of neutral molecules such as H2O and CH4. These solids are held together by intermolecular forces, and we have to remember that there are three types of intermolecular forces: dispersion forces, dipole-dipole forces, and hydrogen bonding forces. And these forces are considered to be weak forces. The second type is called ionic solids, and these solids are made up of cations and anions, such as sodium chloride and calcium oxide. These solids are held together by ionic bonding, and these are considered very strong forces. The third type of solid is called atomic solids, and atomic solids have three subcategories. The first one is called group 8A solids, and these solids are made up of group 8A elements, like helium and argon. These solids are held together by dispersion forces, and they are considered to be very weak forces. The second type of atomic solid is called covalent network solids, and these are made up of minerals and non-metal atoms, such as diamond and sand. And these solids are held together by covalent bonding forces, and they are considered to be strong forces. The third subcategory is called metallic solids, and these solids are made up of metal atoms and metal cations, such as iron and copper. And these solids are held together by metallic bonding forces, and they are considered to be strong forces. Let's take a look at an example. Decide what kind of crystalline solid each element or compound in the table forms and what kind of force holds the solid together. Then rank the solids in order of decreasing melting point. So they want us to put a 1 next to the solid with the highest melting point, and if it has a high melting point, then that would suggest that it has very strong forces. And then 2 next to the solid with the next highest melting point, or the next strong forces, and 3 for the element or the solid that has the lowest melting point, which means it has the weakest forces. So let's take a look at these compounds. The first one is O2. And O2 is a molecule, so it's two nonmetals coming together. So this would be considered a molecular solid. And O2 is a nonpolar molecule, so it is held together by intermolecular forces, but we have to be a little bit more specific. Since it's nonpolar, then it's held together by dispersion forces. C is a nonmetal atom, so this falls under the category of covalent network solids, and for ALEKS we have to list that as an atomic solid. And because this is a covalent network solid, this is held together by covalent bonding forces. NH3 is two nonmetals coming together, so it does fall under molecular solid. We have to examine this structure. NH3 if we look at the structure, H is bonded to nitrogen. So molecular solids are held together by intermolecular forces, but we have to be a little bit more specific. Since H is bonded to nitrogen, then the force is called hydrogen bonding forces. Now that we have our forces listed, we want to also examine the melting point. The one that has the highest melting point means it has the strongest forces. So between dispersion, covalent bonding, and hydrogen bonding, covalent bonding has the stronger force, so it would have the highest melting point. Now, between dispersion and hydrogen bonding is stronger, so it has the rank of number 2, and dispersion forces have the weakest forces, so they have the lowest melting point. Let's take a look at another example. We have these 3 compounds, ZnBr2, that is a metal with a nonmetal, or a cation with an anion. So this is an ionic solid, and ionic solids are held together by ionic bonding. We have HBr, so 2 nonmetals coming together, so this is considered a molecular solid. Molecular solids are held together by intermolecular forces, so we have to be a little bit more specific. So this is a polar molecule, so it's held together by dipole-dipole forces. The third solid is Kr. Kr is krypton, and that is in group 8A. So group 8A solids fall under the category of atomic solids, and group 8A solids are held together by dispersion forces. The next thing we want to do is go ahead and rank these forces. The one that has the highest melting point would mean it has the strongest forces. So of these 3 forces, ionic bonding is the strongest. And between dipole and dispersion, dipole is the second highest, and dispersion is the weakest. So the weakest forces would have the lowest melting point. Let's take a look at another example. We have 3 solids. The first one is Fe. Fe is a metal, iron, so that is considered a metallic solid. And metallic solids are held together by metallic bonding. The second solid is CH3Br. So this is considered a molecular solid. And molecular solids are held together by intermolecular forces. So we have to examine the structure of CH3Br, and we see that this is a polar molecule. So polar molecules are held together by dipole-dipole forces. We have Kr again. Kr is krypton and is in group 8A. So this is considered an atomic solid. And atomic solids, we have to be specific since it's group 8A, then these are held together by dispersion forces. All right, now we want to rank the melting points. The metallic bonding is the strongest of these forces, so this would have a high melting point. And between dipole and dispersion, dipole will have the second highest, and dispersion would be the weakest. Let's take a look at another example. Our first compound is K2O. So this is a metal coming together with a nonmetal, or a cation coming together with an anion. So this is considered an ionic solid, and ionic solids are held together by ionic bonding forces. And the second compound is F2. That is 2 nonmetals coming together. So this is considered a molecular solid. And this molecular solid is held together by intermolecular forces, but we have to be a little bit more specific. This is held together by dispersion forces. And the third compound is H2O, 2 nonmetals coming together, which means it's molecular. And this molecular solid is held together by intermolecular forces, but if we draw out the structure of H2O, we see that hydrogen is bonded to oxygen, which means it's held together by hydrogen bonding. Okay, now let's examine the forces. Ionic bonding is the stronger of the forces, so this is going to be number 1. And between dispersion and hydrogen bonding is stronger, so H2O is number 2. And F2 has dispersion forces, which is considered weak forces, so that's number 3. Good luck and keep practicing.